Hello, I am Subbalakshmi. We have seen in the last video that by applying stoichiometry, one can understand how much of reactants are required to get the required amount of the products. But sometimes the reactants may not be available in as per the stoichiometric quantities. Let us take one simple example. Pongal is one of the popular dishes of South India. For this, Grandma's recipe recommends rice and moong dal or yellow lentil is to be taken in the ratio of 2:1. Suppose we have 3 cups of rice and only 1 cup of yellow lentil available with us, then we have to mix 2 cups of rice with 1 cup of yellow lentil to prepare the dish, and 1 cup of rice will be left behind, although we started with 3 cups of rice were available. This is due to the availability of the yellow lentil, just only 1 cup, and this limits the quantity of the product, that is pongal, and thereby yellow lentil acts as the limiting agent here. We can apply this to one simplest chemical reaction and explain. The combustion of carbon in air to produce carbon dioxide. 1 mole of carbon reacts with 1 mole of oxygen, that is 12.01 grams of carbon combines with 32 grams of oxygen to produce 1 mole or 44.01 grams of carbon dioxide. If only 6 grams of carbon is burnt in air, that is in excess of oxygen, the amount of carbon dioxide produced will be just 22.005 grams. Hence, carbon is the limiting reactant here, just like 1 cup of yellow lentil in the example explained. Let us work out the problem. 90 grams of ethane burns in the presence of 448 grams of oxygen. Find out the limiting reagent and also the amount of carbon dioxide formed in grams. The quantity of available ethane as per the problem is 90 grams, and just because it is smaller in quantity when compared to that of 448 grams of oxygen available, we should not jump to the conclusion that ethane is the limiting agent. We have to calculate how many grams of oxygen are required to react with this 90 grams of ethane. The first step is writing the balanced equation, which we have already done. Then let us follow the stoichiometric process of calculation. In this, the first step is finding out the number of moles. Since we are starting with ethane, that has to be written first. It is 90 grams ethane. This is to be converted into moles. Therefore, how many grams of ethane make 1 mole of it? It is 30.07 grams. Therefore, it has to go to the bottom and mole has to come to the top. We can cancel off the common terms. So, this is the number of moles of ethane. The second step is the mole ratio. Since we are looking for oxygen, that has to go to the top. Oxygen, what is the coefficient of oxygen? In the equation, that is 7. And as per the equation, the coefficient of ethane is 2. So, 2 ethane. Next one, we have to convert. This is the number of moles of oxygen that will react with 90 grams of ethane. Then we have to convert it into grams. Therefore, how many grams of oxygen make 1 mole of it? All of you know that it is 32 grams oxygen, and mole has to go to the bottom. Next one. Common terms are to be cancelled. Now we have to take our calculator and do it. We are left with 90 into 7 divided by 30.07, again divided by 2, and the answer is to be multiplied by 32, which will end up with 333 grams of oxygen. Is there sufficient amount of oxygen? Yes. The amount of oxygen present originally is 448 grams as per the problem. Now 90 grams of ethane will consume 335 grams of oxygen. That means there is sufficient oxygen, and the reactant which is completely consumed first is ethane. All the 90 grams of ethane will run out now by this stage. So, as per the definition, the reactant which is completely consumed and runs out first is the limiting agent. It applies to the ethane here, and this is the limiting reagent. The next question that can be asked here is, which reactant is in excess? Obviously, it is oxygen. And how much of it is left over or unreacted? It is very simple. For that, the initial amount of oxygen is how many grams? 448 grams. How much is consumed? That is 335 grams of oxygen. So remaining is 448 minus 335 will give the answer 113 grams of oxygen is left behind. One more question in the problem is how much of carbon dioxide is formed. It has to be kept in mind that once the limiting agent is decided, any further calculation should be based on that only. So we have to start with 90 grams of ethane. Again, let us apply the stoichiometric process. 90 grams of ethane. As usual, the first step is converting into moles. We have done already the same procedure, 30.07 grams into, now we are looking for what? Carbon dioxide. So for the mole ratio, carbon dioxide has to go to the top, and as per the equation, what's the coefficient of carbon dioxide? It is 4CO2 divided by, we have started with ethane, therefore ethane has to come to the bottom, 2 ethane. This is the number of moles of carbon dioxide formed, and the third step is converting it into grams of carbon dioxide. How many grams of carbon dioxide make 1 mole of it? It is 44.01 grams. Divide by mole. This will give the answer. Before that, let us first cancel the common terms. This is ethane. Now we are left with 90 into 4 divided by 30.07, again divided by 2. The answer multiplied by 44.01 will give the answer 263.7 grams of, 263.7 grams of carbon dioxide. This is the amount of carbon dioxide formed. Hope you would have understood the concept of limiting reagents. Let us meet in the next video